Okay, guys, so last day we looked at using inequalities within linear statements. So we were looking at bigger than, less than, or bigger than or equal to, or less than or equal to. And today we're continuing on with that and looking at adding, subtracting linear inequalities. So I'm going to share my screen and go here. Perfect. Okay. So, and then I'm going to stop recording myself. Okay. So on this screen here, we can see it's not a very big set of notes here, but looking at what we call the addition principle for inequalities. And that is if we have three quantities, A, B, and C, and let's say they're real numbers, so any number that you can fit on the number line, and you're told that A is less than B, then if you add C to both sides of the equation, the inequality should still be true. So let's give you an example of that for the first statement here. So let's say that, where does draw? So let's say that you said something like 2 is less than 3. So I think we would agree that's true. And you decided you were going to add, let's say you're going to add 4 to each side. So would the inequality still be true if we did that? So if we said 2 plus 4, so we add 4 to each side, and then we would now get 6 on the left side, and we would get 7 on the left side. And so would the inequality statement still be true? So should we still use that symbol? Would that still be true? And it would be. And what if you did negative numbers? Let's say that your C value, or you're minusing 5 from both sides. So you still start with a statement like maybe, let's make it small. Let's make it, let's say 1 is less than 4. And let's say we subtracted 5 from both sides. So would the inequality statement still be true here? So 1 minus 5 is negative 4, and 4 minus 5 would be negative 1. And so would it still be true to say that? Well, yeah, if you were looking at negative 1 on the number line, so negative 1 would be here. Well, negative 4 would be over on the left side, so it would be less than negative 1. So these statements we have here basically are saying if you add and subtract the same number to the original statement, this statement should still be true, or that the inequality sign should not switch in that case. Okay, so that's really the big principle we're using, and here's a question that would kind of relate to that. So let's take a look at an example. Let's say you had x minus 5, and that is less than 3. So if I was to want to move the 5 to the other side, I would add 5 to both sides. So add 5 here. So we use the addition property. And then I would get x on this side, and I would get 3 plus 5, which would be 8. So would I want to switch my symbol or keep the same symbol? Well, above it says if we add the same number to both sides, the symbol should stay the same. So we just added 5 to both sides. So it should still be less than 8. So let's see if we can check that. We'll check that solution. So you could pick any number that's less than 8. So I'm going to pick 0. That's a pretty nice number to plug in. So if you plug 0 in, you get 0 minus 5 is less than 3. So negative 5 is less than 3. And that is true. And of course, any number that's less than 8 should work if you plug it in. Okay, so let's try a different example. Let's say we had a bit more stuff here. Let's say you had 5x minus 2 is less than or equal to, let's say 4x minus 5. Let's go minus 3. Let's mix all the numbers up here. Okay, so the first thing I would want to do is group my like terms together. So I think I would want to maybe move the x's to the other side, or to one side. And so I'm going to move them in a way that reduces the number of negative signs. So I have 5x on the left, 4x on the right. So let's minus 4x here. Minus 4x. And I'm going to also add 2 to both sides of the equation. And see what happens when I do that. Okay, so I know 5x minus 4x is just 1x, and I know negative 2 plus 2 is 0, which is why I moved it over. I know 4x minus 4x is 0, and then negative 3 plus 2 is negative 1. So what symbol would I put between these two things? I mean, it was less than or equal to here. And all I really did was add and subtract numbers from both sides. So as long as you do that, we should still be less than or equals to 1 here, -1, sorry. So I'm going to pick, I'm going to check this, and I'm going to put -2 in for x here. So I'm just going to go up here and do that. So I have 5 times -2 minus 2 is supposed to be less than or equal to 4 times -2 minus 3. So I would get -10 minus 2 is -12. So is that less than or equal to -8 minus 3? So that would be -11. And so -12 is actually less than -11. So that's true. And of course, any number that's less than -1 should have worked. Now, had you put -1 in, though, what you would have had is both sides equaling each other. So you want to be aware that still would be true because the symbol is less than or equal to. Okay, so really this is just saying that as long as you add and subtract any number from both sides, you don't change the symbol. So the symbol just stays the same. There's no alteration to the symbol. Now, a few weird things can happen when you solve these kinds of questions. We should just give you an example of the strange stuff that can occur in math. So let's say you had a statement like x is less than x plus 2. Okay, so if you were going to solve this, I think what I would do is I would try to get all the x's to one side. So I'd maybe move the x's to the left-hand side. So it's good to have x's over there. So I'm going to subtract x from both sides. And this is where something strange happens now. So if you said x minus x, you would get a 0 on this side. And then I would get x minus x is 0, but then I'd be left with a 2. And then I have this symbol in here that's less than. Now in math, sometimes you can lose variables and you get these statements that are not true, or sometimes they are true. So here the question is 0 less than 2? Well, that is true. So if you get rid of your x's and you get a true statement, what that actually tells us is that there is an infinite number of solutions. So any number you plug in will work. There's not just a set number, there's actually an infinite number of solutions. So if you picked 5, you put 5 in, you get 5 is less than 5 plus 2. So 5 is less than 7. If you pick 10, you get 10 is less than 12. If you pick 0, 0 is less than 2. And so there's an infinite number of solutions here. Now, it might actually make sense if you said, let's say x was your birthday, and I said, your birthday today, would you be younger than 2 years from now? So if you took your birthday and added 2, well, obviously 2 years from now, you would be older. So your birthday now would be younger than what you'll be 2 years from now. So that's kind of what this is saying. Or if you had a certain amount of money and I gave you $2 more than that, well, then your initial amount of money would have to be less than what you started with. Now, another weird thing that can happen, though, is you get a false statement occurring here. So let's sort of give you an example of that. So let's say you had x plus 2 is less than x. Okay. Okay, so I'm going to pause this here. Okay, so last scenario here. So let's say we move the x's to one side. I'm going to minus x from both sides, minus x, and I'm going to subtract 2, minus 2. Now, I might want to just write this, and really there's no number here, so it's like a 0 on the end. So if I minus that, I'm going to get x minus x is 0, 2 minus 2 is 0, so I get a 0 on this side. And I get x is canceling, and I get -2 here. Now remember, all I did is add and subtract numbers from both sides, so I don't switch the sign, I keep the sign like that. So is 0 less than -2? Well, that statement is false. And what that means is there is no solution. So if, whoopsie, no solution. So if you solve a question and the x's vanish on you, then you can get a true statement. So you can get a true statement, or you can get a false statement. So this is when x, the variable, cancels. So if the variable cancels and you get a true statement, then we say there are infinite solutions. And if you get a false statement, we say there are no solutions. So like how I switched the colors there, really just to make it confusing. Okay, so true statements, infinite solutions, false statements, no solutions. Okay, so I'm going to assign some homework on this, and I hope that helps you.